All right, so we talked a lot about solving equations. That kind of covers sections 2.5 and 2.6. I think your first homework assignment in My Open Math is going to be section 2.6, where you get to practice a bunch of challenging equation types. But then you have an assignment for section 2.7, the final section in chapter 2, which is about inequalities. So we've been doing all this stuff with equations when things are equal, but what about inequalities, where things might not be equal, but they are at least related to each other by in some way, like one is bigger than the other or something. So we're going to deal with less than, greater than, less than or equal to, or greater than or equal to. Now, inequalities are different from equations in that they can have infinitely many solutions. They often, almost, in fact, many times have infinitely many solutions. Like in this case, if we ask x is less than 5, then, 4 is a solution, but so is 3 and 2 and 1 and 0 and -1 and so on. But so are all the other numbers in between those integers, like 4.875, right? And some irrational number like pi is less than 5. So there's tons of infinitely many answers to this. And so we want to find some way of representing all those solutions and then writing them down with a notation. We're going to introduce something. You may well have seen this notation before. This probably is review, but we all want to be on the same page here. We want to introduce interval notation. Interval notation, which is a really useful way to talk about infinite sets of numbers. So first of all, x less than 5. Before we get to interval notation, let's just graph what that would look like on the number line. So we have our number line, and 5 is going to be somewhere. Say 5 is here. The solution set for this inequality is all numbers that are less than 5. So anything over here to the left is going to be part of our answer, going all the way out towards negative infinity, which is sort of like the direction. It's like going left, right? What would be at the end if you could ever get to the end? You don't ever get there, but that is towards negative infinity. Now, since it says less but not equal, right? If it were equal, we'd have a line underneath this. Less but not equal, we're going to put an open circle right here. That means we're coming all the way up to 5, but then we're not actually going to include 5. So that's how you graph that solution set on a number line. To write it in interval notation, we're going to put the number on the left and the number on the right, sort of the boundaries of this interval. And since it goes off forever on the left, we're going to write negative infinity. That's the infinity symbol, and it's negative here. So that means like all the way from the left, all the way up to 5, right? And then we have to put either parentheses or square brackets around these, and they can be different on either side, depending on whether or not the number is included in the set. So with infinity and negative infinity, you always use parentheses because those numbers aren't actually real numbers. They're sort of more like directions. It's like saying east and west, right? You can't ever be at east or at west, right? You can just go towards, like, to the east or to the west. So negative and positive infinity are like that. You can't have them included in your answer because they're not numbers, but they do serve as the boundaries in a way. So from negative infinity all the way up to 5, not including 5, and so we're going to use parentheses there too. The parentheses are for not including. So that's the interval notation. That's the solution to this inequality. If it was instead something like x is, say, greater than or equal to 5, okay, on the number line we'd have 5 somewhere, and now we'd use a filled-in dot because it says equal to, okay, and then we go off to the right because it says greater, right? And then in this one, now 5 is on the left, and on the right is infinity. Since it's allowed to equal 5, we'll use a square bracket this time instead of a parenthesis. But for infinity, it can't actually equal infinity. That's never allowed, so we'll use a parenthesis again. So that's sort of how you use, that's basically the basics of interval notation. And I'm also often going to ask you to actually plot the solution set on a number line like this. Yeah, let's do another example where we have a little more work to do. Let's say you've got a compound inequality. That's where you have more than just 2 expressions compared to one another. In this case, we're going to have 3 expressions all compared to one another. 2 is less than or equal to 8 minus 3x, which in turn is less than 17. We're asking what x values are going to satisfy this. Well, we can solve this much like we solve an equation by doing things to both sides, or in this case, all three sides. So we want to isolate x just like we do with solving equations. So the first thing I want to do here is get rid of this 8 so that I'm down to a single term. That sounds like a good idea, right? So let's subtract 8. I'm going to subtract 8 from all three sides of this inequality statement, right? Every single place. So we're going to have negative 6, less than or equal to, here these cancel, and we just have negative 3x, which is less than, let's see, that's going to be 9, right? All right, so now what we would want to do to isolate x is divide by this constant it's multiplied by, right? So since it's multiplied by negative 3, we'd want to divide by negative 3. But there is a rule. There is a rule. I'll write it down. When multiplying or dividing both sides of an inequality, by a negative number, always flip the relation symbol. That would be the inequality symbol. So in this case, we're going to divide everything by negative 3. But when we do that, we have to flip our inequalities around. So negative 6 divided by negative 3 is positive 2, but this is going to become greater than or equal to. Here, the negative 3's will cancel. We have x. But this 9 divided by negative 3 will be negative 3. We have to, again, flip our inequality symbol around. That is essential. And the reason for that has to do with reflection. When you multiply or divide by a negative, you reflect over 0. And then anything which was, like if you're reflecting, if I have ring hand is on the left and other hand is on the right. If I reflect, now my ring hand is on the right and my other hand is on the left, right? So that reflection causes things to, like the order to change, right? The order swaps. So that's why the inequalities have to swap as well. Let's just rewrite this in the other way. I'm going to kind of flip this around and write negative 3 is less than negative 3 is less than x, which in turn is less than or equal to 2. It's kind of reading it like from right to left, okay, and then rewriting it. And that makes it nice and easy to convert this to our interval note. Well, first of all, we'll do a number line. Find negative 3 and 2. They'll be in that order. It'll be open here at negative 3, and then we'll fill in all the way until we get to 2, and then it'll be closed. Okay, so that's what the number line graph looks like. And then the interval notation is negative 3 comma 2, and we're not allowing equal to negative 3, right? But we are allowing it to equal positive 2. So that is our solution to that inequality. All right, I'm going to do one more, I think I'm going to do one more inequality example, so one more video this week.